Welcome, everybody. We're just about to start today's masterclass session. I'm Gilles Perez. Very nice to meet you. It's great to have everybody online. We see people are joining. We have already a few that are here, so thanks for being on time. And I'm sure that more people will continue to join. But we'll start with a very quick introduction. I'm joined together by tonight by Chez, who's our co-founder and CTO. Hey, Chez.
Hey guys, nice to meet you.
And Aviv, who's our founding engineer. Hey, Aviv.
Hey guys.
All right, I think today we have a pretty exciting session. We're going to talk about two subjects, which I think are very interesting to talk about in the same session. Just because one will be a topic that everybody who's involved in infrastructure and application monitoring will have at least heard of, if not experimented with, but seems to have had a bit of a lower impact than initially was expected, and we're going to talk about that a little further very soon. The other, and of course, I'm talking about OpenTelemetry here. The other topic we're going to focus on is probably the rising buzzword of the industry right now. It's set to revolutionize the entire market, and here I'm talking about eBPF. And it's going to be interesting to hear what both of our experts on both these topics have to say about this. And we really do, I firmly believe we have two of the best people to talk about both these topics. They really are experts on these topics and on these subjects and on observability in general. And it's even more interesting because I know that on some levels you both agree, but on some levels you don't agree, not to say disagree, which I think is the perfect recipe for an interesting conversation. Before we go into that, I just want to remind everybody that we have a Q&A box, which is already open, and you can ask your questions throughout this session to either speaker. We're going to try to get to all of these questions, before the end of the session, if time allows. And you can also ask those questions anonymously, by the way, by choosing that option from the Q&A tab. We also have a chat box where you can ask your questions, comments, or you can just let us know where you're seeing this from. And I see that we already have a viewer from Scotland, so very nice to see you, and you're all welcome to let us know where you're from. So just to kick us off, we're going to start with OpenTelemetry, and I think it's fair to say that OpenTelemetry doesn't need a very long intro. Everybody's heard of it in one way or another. But just as a quick refresher, OTel was introduced in 2019, and its goal was initially to create a framework that everyone can adopt when instrumenting their systems. But it seems that it might have had a lower adoption level than was initially expected. And even if you do have it and you are using it, it's a question of how you're using it. So first question to both of our speakers is, why is OpenTelemetry making so much noise? Are so many developers and DevOps teams wrong not to use it or not to use it extensively? And what also makes it so hard to adopt? We could start with you, Chaz, maybe.
Um, yeah, well, I think when we talk about OpenTelemetry, there are a few parts of OpenTelemetry, right? Aviv, do you want to take the SDKs? I remember just lately you tried to instrument an application with OpenTelemetry. How did that go?
Well, it did work, but yeah, it took a bit of an effort. Yes, of course, there are the SDKs for OpenTelemetry. I think in general, it's important to distinguish between the specification itself that is OpenTelemetry, which basically establishes a way how to collect telemetry data and how to transfer it from the actual SDKs that perform this. And of course, there's the third part, which is actually not part of the spec, is the backend, how you save your data. And I think that's one of the reasons that a lot of developers really like this new concept. This new idea is that you don't have to continue switching the way that you gather that the data from your services every time you switch a vendor or you do something like that. You can still, in theory, keep the same things that you already did, but just send it somewhere else, which is a really cool idea. I really like that idea.
Yeah, I agree. I think that's also, to me, that's the big game changer here. I think before that, the cost of changing vendors was so expensive because, as I said earlier, as I hinted that Aviv was a bit struggling with the auto instrumentation of our Golang application. Imagine that you need to instrument your application again after you just change the vendor. I think in that aspect is OpenTelemetry is definitely changing the game in terms of observability data. First, by just defining or crafting the schemas, putting everyone together, all the vendors as well, and the community, and making decisions about this is how span should look like, this is how metrics should look like, even logging, and maybe in the future, probably we'll talk about it later, even profiling will get adoption. So I think, yeah, OpenTelemetry is changing the game of observability, and you as developer definitely should look at instrument your application with OpenTelemetry. I think that the main question is, how much effort are you willing to put into getting all those signals? Imagine now you have, I don't know how many microservices a company has now, but so imagine you have plenty of microservices, and now you need to instrument all your application with OpenTelemetry. Some of the runtimes will work out of the box, and that's amazing, and it's really impressive when it happens. Some of it will not work, and you have to manually do that. So I think all developers should look at the core application they have, and those applications that they're pushing as hard as they driving the business. But the rest of the application, that will be harder to get to. And I'm not even talking about third parties and other applications that you can't change the code for it.
Yeah, so I was just one more point on that. I was gonna talk about third-party applications, and I think that at the end of the day, you have a lot of code running in your system that you're not even aware of, and whatever you do with OTel, you're still not going to be able to get a really good picture of everything, and it has to do with how difficult it is to instrument. I think it also has to do with how difficult it is to keep doing it at scale. And it's not just, you mentioned a lot of microservices. I think the other problem is a lot of teams that are indeed writing in different frameworks, and making sure everyone knows how to do what they need to do and actually continue doing it, so as a project gets bigger and bigger, is a really, really big challenge. I think it's very hard to actually achieve that in real life production systems.
Yeah, I definitely agree, and we all saw that. I think when we're just doing our job, and you see that you're missing something, right? You see the distributed tracing, you see there must be another link here, and you realize, there's another service, another library, another framework that I didn't do. It could be very frustrating, but when it works, it's amazing. It's like magic.
Now, do you feel that it's essential for modern observability solutions to integrate with OTel?
I think it's a very good question about essentials. I think we're shifting from, that in the last 10, 20 years, we were focusing around logs, right? So logs, and then we started using metrics, and then because we couldn't digest so much logs. Um, and then we realized we need some kind of tracing that will help us understand why things happen in a more structured way. Because you can think about spans or traces as a structured logs in a way, that someone put in the right places. Um, I don't think it's mandatory. I think you need some kind of a way to measure your golden signals, for instance. But you can get a golden signals even without auto. And I'm not just hinting for eBPF. You can do that with metrics as well. I don't think it's mandatory, but I think it's very helpful to have it. There is a fine balance between how much effort you need to do in order to get those spans, and how much do you find it helpful in troubleshooting. So if you're writing code in C++, I don't think it's a good idea to instrument your application with auto. It's just going to be very difficult, and I think even Golang application, it could be very frustrating. So I wouldn't say it's mandatory. I wonder what you think of it. What do you think as an engineer?
I think that having something is mandatory. Like you said, I'm not sure. It depends on what. I mean, a lot of developers really like working with logs, which makes sense. It's the most intuitive things that you can do, and it's very easy to see. But I think that at the end of the day, I would suggest having some kind of a mixture of metrics. I love metrics. Metrics are, I'd say, they're relatively new to me as an engineer, and it's amazing what you can do with those once you understand where to put what's the correct places to put them in your program. But yeah, you don't necessarily need auto for that. It's a really good place to start. I think that if you're already thinking, well, I need to for some reason I want to instrument my applications and get it going, then accept eBPF. It's a really good place to start, I think.
Yeah, definitely.
Cool. So moving on to maybe start talking about eBPF a little bit, but we'll start weirdly with a quote from from the OpenTelemetry website, which says that in order to make a system observable, it must be instrumented. Now, I saw a recent survey by Kong that was mentioning that on average, organizations will have about 184 microservices. So let's talk a little bit about instrumentation with eBPF compared to traditional methods. And of course, groundcover, was founded to change the way organizations monitor applications and systems using eBPF. And interestingly, eBPF was actually set out to be used for debugging your kernel, so a totally different field. But it seems to have a huge promise for observability, and of course, this was identified very early on by the groundcover founding team, which includes, of course, both of you. But can you talk a little bit about how eBPF is set to change the game for observability?
I think you just said it, because how many said you 180 something?
184, yeah.
Yeah, I just think how complicated it is to coordinate the instrumentation of 184 applications. Just the organizational coordination. And I'll bet some of the applications are no longer maintained, or the teams that built that already doing something else. I would assume probably 10, 20, maybe even 30%, depends on the industry, are probably compiled runtimes. That will be very hard to instrument. So I think there's a big misconception about eBPF, that we used to say OTel is the auto instrumentation, and eBPF is, it's not. You don't need to instrument your application. Both are auto instrumentation, right? Just being done like by someone else with different techniques. So auto instrumentation, when we talk about auto, is an SDK, some code that runs and patch your code, or add some lines of code that to decorate your code. Um, with eBPF, it just been done by the kernel and the programs that people wrote, Aviv, for an example, that actually know how and when to capture events. So I think eBPF gives you the power to automatically instrument your application for all those 184 applications that runs in your cluster in under 5 minutes. So that's to me is a game changer, and not only that you spare the time to instrument it. It's not just one time thing to instrument your application. You need to constantly work and add more instrumentations every time you add a library, every time you change versions. So for your dependencies, I just had a talk with some great guy engineer that I appreciate. He said they upgraded their dependency lib, and instrumentation stopped working. So it's not just one time thing that you do and forget about it. So you have to keep instrument, and you have to keep work on that. So to me, eBPF is it's another way to auto instrument your application. It's very holistic view. There is no escape from eBPF. If you're firing an HTTP request, eBPF will capture it. If you do an SQL API there, eBPF will capture it. And if you think about it, even it's more than just API network calls. You want to capture the slowest disk write or IR latency. Those things will be very hard to instrument. Anything that's more close to the kernel, I think, will be very hard to instrument, and those things matter. Usually, those are the hardest bugs to debug and troubleshoot. So I think eBPF is definitely the way I would go to an auto instrument application. Um, yeah, I wonder. I'm curious to hear Aviv thoughts about that.
Yeah, so I think what you started with saying that you have to instrument your application in order to get observability. And I think this is one of the points where me and Chez are kind of in disagreement, not in the sense that you don't need to instrument, but in the sense that, well, what is instrumentation exactly? So I do think that eBPF is a form of auto instrumentation, but the key difference here is that you don't affect the code of your software by doing it, by using it, which I think is seems like a minor difference. What does it matter if I'm touching code inside my application or I'm doing it from somewhere else? But it actually makes a large difference for a few reasons. I think one of the biggest ones, and this is something that I personally think is not very well known, is just how big the impact of using an SDK. It's not specifically OpenTelemetry, but an SDK that changes your code, that includes third-party code inside the flow of your code, just how much overhead that adds to your applications. And I think it's a problem that is essentially impossible to even measure, because who is responsible for noticing how much CPU, for example, increased when you added auto instrumentation? I mean, which team is responsible for what? It's a very difficult thing to grasp. But not only did we've seen this happen in multiple environments for customers where the impact is much larger than anyone would anticipate. And I think the key point here is that eBPF allows us to not interfere with the application. It has some overhead. It's not that it's not free. Nothing is free, but it's a few order of magnitudes lower than what you would get from an SDK. And I think another thing that comes to mind in this specific subject of why is it revolutionizing observability is that I said before that I think one of the premises of SDK of OTel is that you could just instrument once and you don't have to change your instrumentation as you switch between vendors, for example. But I think that even once is too much for a lot of teams, for a lot of people, because while observability is nice, I think it's still lower priority than making your product work. A lot of teams will not get to observability, and even this one-time thing will just never happen. So being able to basically save all of this hard work out of the box is, to me, it was mind-blowing, to say the least. I mean, it's amazing to see it work out of the box like that.
I agree. I think when you said that, I kind of realized the first law of measuring something is like, unless you're doing quantum, don't change the environment you're observing. And I think, and even when we did the benchmark for auto instrumentation, I was a bit shocked to understand the, the, the impact that auto or any other SDK instrumentation, right? We've been testing Datadog as well, and New Relic as well. It's kind of the maybe it's necessary, but you kind of change the state of the application that you are observing, and if you're just increasing memory and or taking CPU cycles in a way that affects the application itself, you're kind of messing with the actual results. And I think that's something that eBPF is definitely doing very, very brilliantly in the way that the verifier is making sure you don't run more than X instructions, and you can make sure your code is safe to run and not changing anything in the environment. I think it's very, very powerful. I agree.
Okay, so I'll stop for a minute because we have a few questions already in the Q&A, and I want to I want to try to address them while we're on the topic. I think you addressed a few of those points, but let's hear what you think of this. Um, so Aviv, I'm sorry, this is covering your face right now, but let me write the question and then I'll take it off screen. David is asking, when using New Relic or similar that has a dedicated SDK for the application, how big a difference is the instrumentations in regards to eBPF versus that dedicated SDK? And just in general, maybe what will we miss when using eBPF OTel ground cover?
Yeah, I think it's a good question. I think I'm not sure if I understand the question completely, but I'll just answer the second part. Um, so I think the main point, maybe we're going to talk about it later, but I think the main point is that with eBPF, we're not changing we're not changing the code itself, so we cannot use context propagation. Which context propagation is pretty important if you want distributed tracing to work. So if you want to see A talking to B, talking to C, talking to E, and they're all related in a specific example, that's still, and maybe we'll talk about it later. That's still not possible with eBPF. I know Aviv has some cool ideas about it, but currently it's not supported. Um, Rather than that, I would expect that you get a lot more information from eBPF. So a lot of our customers, we're talking to them and saying, okay, how much of your environment covered by auto? Or people think maybe 50%, 60%, and when we deploy ground cover, we actually see something around 10%, 15%. So I would expect to get a lot more information with a lot less overhead. And you can still have dependency map, but you can have distributed tracing, and I think that will be solved in the future. But it's another topic.
Cool. You know what? Let's stay on the topic of hearing what you've said before. It could seem like eBPF is the perfect solution. I'd like to hear what you both think about it. Is it the perfect solution? And maybe try to challenge you a little bit to talk about the maybe disadvantages or limitations of eBPF. I think you mentioned already one, and we can talk about distributed tracing a little bit further. But yeah, what do you think about that?
Yeah, so I think on the subject of distributed tracing, I think that's the one big thing that is still not very possible with eBPF. There are some, I would say, POCs or some support for specific libraries. Actually, by the way, OTel the auto instrumentation for Golang today, for HTTP at least, uses eBPF under the hood. It does so in a manner that is we don't personally like in ground cover because they use a debug feature which does allow eBPF to manipulate the data that is being transferred. And basically you can inject this context propagation that Chez was talking about. But this, in my opinion at least, kind of goes against the promise of eBPF of first do no harm. Basically, if something changes, for example, in Go, in the way that the Go HTTP libraries are implemented, which it will change, that's just the way things are, then you can just simply break an application and crash it instantly. And that's to say that eBPF, you need to know how to use eBPF. Maybe I'm jumping around a bit to why is it not exactly a perfect solution? Because it's difficult to build. So I think that as a user, you can enjoy it after someone did a lot of work to build it. But I think that's, let me get back to the first problem. I think with distributed tracing is basically a matter of understanding how you can get the same kind of context propagation with eBPF is something that we think is possible, something that should be able to implement in a way that supports the absolute majority of SDKs and frameworks. But it is, without a doubt, I think the biggest technological challenge for observability using eBPF today. And I very much think that we'll be able to get to it. I don't know what Chez thinks, but I'm pretty sure that sometime in the future.
I think distributed tracing is something that is probably 85-90% solvable with advanced usage of eBPF. And I know we're groundcover looking into it, and I believe we definitely will achieve that in the future. Um, I think there are some other aspects that are more open telemetry by nature, like native to open telemetry. So imagine, and those are, we talked about auto instrumentation, which is a big part of OTel and eBPF. I think manual instrumentation will be a lot easier to do with auto. So imagine you have this function that you want to measure how many times, or you want to measure distribution of some kind of parameter you get on those functions. I think it would be not really efficient to get that with eBPF. I know it's very possible with Golang or C++ or C to do that, but I think um, in general, I think that the easier way to do that will be with OpenTelemetry. So manual instrumentation, I think, belongs to OpenTelemetry more than eBPF. I think eBPF should get all the auto instrumentation. This. I know some people say safety net, but I would like to call it like an holistic view of everything. Nothing can escape eBPF. So I think that will definitely be the eBPF case to go. If you want to know exactly where things are going, who's talking to who, when, how much, uh, any status code, any SQL query. If you want payloads, body, request and response, headers, everything to get just observe everything, you probably go eBPF. Um, if you want manual instrumentation, add labels, specific business logic, it's probably Auto. I think distributed tracing will be um, very interesting to solve, and I think we're definitely capable of solving it. Um, and I think the last point we'll have to talk about is it's collecting logs with eBPF. Is that something meaningful? Is that something that we should do? I don't know. What do you think of it? That's the last signal. Profiling is already done. What about logs?
Yeah, so um, I think that just a while ago we were start talking about doing the actual log collection with eBPF, and I think the moment that it came to start thinking about I realized just how perfect eBPF is for log collection, because the whole idea, the whole concept behind eBPF is an event-driven architecture. Basically, every time that something happens in the kernel, then you get the chance to observe it and maybe remember something about it. And logs are essentially the most basic event-driven thing I can think about in terms of an application, because you just write something, you just write something to the file or std out, or it doesn't matter. And when I started actually looking into it, it turns out that the way that log collection is done, which it's considered relatively solved, I think, in terms of there are a lot of solutions that are doing it pretty good. But just like other things, just like SDKs, it turns out that the way that it is being done by container runtimes, for example, turns out to be pretty expensive in terms of performance. And these are the kind of things that once you once you start thinking about it, you realize just how much work needs to be done in order to make it happen. And I think that being able to collect eBPF with logs as a way of thinking, not just as a feature in a specific platform, but basically making that a way that logs are being collected from an application, is something that I definitely will be looking forward into investigating. But I think we'll see more of that in the upcoming year, maybe two. I'm not sure. Yeah, it's very exciting for me.
Yeah, and I think we're just starting. We're just scratching the surface in terms of what other signals that are very hard to get, like network, disk, profiling,
Yeah.
CPU on time, off time. I think we're just getting started in a way.
Cool. So just to kind of bring it all together, we have, as you can see probably in the chat, we have people from around the world, which is very exciting. And thank you again, everybody, for joining, and thank you for sending in your questions. I'm sure some of you would have heard of groundcover, some of you may have not. So just to put everything into context, groundcover has a unique and proprietary eBPF powered sensor, which integrates seamlessly with OTel. And it was all built on an in-cloud infrastructure, which we didn't talk about, but we could definitely even dedicate a full masterclass just on that. But can you talk a little bit about how all of these things help set groundcover apart from everything else that's on the market right now?
Yeah, I think in just what we talked about, we know it takes a few months to onboard a company to instrumentation and tracing metrics, logs, and so imagine you can reduce that time to 5 minutes, and it's not just the onboarding time. So imagine that you have some kind of holistic view of everything that's going on. No matter the changes you're doing, you get all the signals in one place, and so that's to me was when we started ground cover, that was the goal. I mean, we were working so hard to get those signals from the applications we've built. So to me, eBPF was just around getting all these data automatically, and don't need to work hard for them. And then you have all this information, right? You get 10x more data you have, and you're already paying so much money for your vendor, observability vendor. I think we didn't talk about in cloud, but the core concept of ground cover is built around decoupling price from pricing from volume. So imagine now you have 10x more information to debug your application, but you don't need to pay 10x more. I think that's those two, the time to market, time to value, and decoupling the price from the volume are two different differentiators that I think we hear a lot from our customers that they really like.
Yeah, and I think just to add on that, just to wrap up, the eBPF versus OTel is more like the eBPF and OTel. I think it's just that in ground cover we collect most of our information with eBPF, but actually we also use the OTel spec, for example, when we save the data, because we do believe that that's the way to go. You need to make it standardized. You need to make it accessible by people who understand what they're seeing and are able to use it elsewhere, possibly. But the ability to have both contexts, to have the OTel that you know and love, and like Ches mentioned, you also have, there are some uses that will probably never get replaced by eBPF for OTel. But at the same time, you have so much more data and you have it for all of the services. And I think that's one of the things that ground cover is really good at. And by the way, not making it too much data. That's also another thing that's important. Just showing the things that you need, but have the best of all worlds.
By the way, we talked about clearly the need right now for eBPF and OpenTelemetry to work side by side and together. Do you see a possibility for a future iteration of ground cover where you no longer need OpenTelemetry and you can rely solely on eBPF?
So I think, as Aviv said, we adopted OpenTelemetry as our format, just to have our data more easily just hook up to other systems or to ingest OpenTelemetry to our system. So currently, if you already instrumented your application with OpenTelemetry, we're just collecting those signals automatically to our backend. Um, I don't see any reason. Maybe if we'll have another spec and it will be better than OpenTelemetry, but I would just say it will probably be OpenTelemetry version version 2 or 3. So we will always use OpenTelemetry as the format, but I definitely can see for most companies, ground cover sensor, which is based on eBPF, can definitely give you what you need in order to monitor and observe your production environments. Definitely.
Cool. So just before we wrap this up, there was one more question that I wanted to that came up in the Q&A that I wanted to share. I'm not sure if you have anything to say about this, but Ranganath was asking, how has the emergence of ahead of time compilations impacted the possibility of implementing end-to-end instrumentation using eBPF?
Yeah, that's a good question. I think it makes it a bit harder because now we need from the eBPF we need to um, correlate um, more abstractions in a way. We need to understand more abstractions, understand how it works. So it definitely makes it a bit more challenging, but not a lot more than the regular Node.js engine, which is complicated enough with the async event loop, or even just Golang, which has the concept of Go routines that can basically have micro threads, like millions of micro threads that you need to track all the time to get distributed tracing to work properly. So I think it changes it a bit, but not in a way that we didn't expect. And I still believe that Aviv can do it. Aviv and the team can definitely do it, and I'm sure later this year we'll probably can demonstrate some of those capabilities.
Great. Ranganath has actually had a follow up to that. He was asking which would be a more effective implementation for this purpose, OTel or eBPF.
For the purpose of end-to-end instrumentation, so I guess it depends how do you see end-to-end instrumentation. If you look at the end-to-end instrumentation in a way that you'll see everything that runs in your cluster, I think eBPF will be much more efficient. But if you're talking about distributed tracing, exactly following up every span, I think Auto currently will be the way to go. Um, so sorry about that. We probably need both at that time, but we are working on that.
All right, cool. So anything else that I didn't ask that you wanted to add to the to our viewers' knowledge, or any final thoughts? No, no is good too. Cool, great. So I don't see any more questions from the Q&A, so I think we'll wrap this up here. I do want to, before we leave, I just want to let you know that we are going to have another masterclass. We have one every 2 weeks. The next one that's coming up is on February 13th, and this time we're going to have Shahar, our co-founder and CEO, together with Bill Mulligan from Isovalent. They're both going to kind of have a follow-up discussion to this, I guess, in a way, where they're going to still discuss eBPF from two people that know quite a lot about it. It's going to be a very good conversation. I think that, well, you're all going to get the email after this webinar for the recording, but together with the recording, you're also going to get a registration link to this upcoming masterclass. So you're more than welcome to join us on that one too. At this point, I think I want to thank everybody for being here. I want to thank Chaz, Aviv for taking the time and for giving us some insightful discussion. It was not as heated as I hoped it would be, but you kept it well, and I think it was very interesting for everybody. I'm more than interested to hear what everybody thinks about this. So feel free to give us your feedback any way you want, via the Slack community or via email. Yeah, so thanks everybody for being here. We'll hope to see you on the next one. All right, you guys.
Thank you.